This video covers transformations of quadratic functions, day 2. So, part 1, they are asking us to graph x squared and compare it with x plus 3 squared. So, in my video, my graph is blue and then red. So, blue will be the original, red will be the new. So, blue and then red. So, what do we notice? So, when we added 3 in parentheses, it moved to the left 3. So from blue, the vertex went 1, 2, 3. And then for part 2, they're asking us, okay, what about minus 3? So if you have a guess, you could go ahead and take it. What do you think is going to happen when we change the plus to minus? And if you guessed move to the right, you would be correct. So it moves to the right 3. So we have a general equation that we used yesterday or on day 1. A parentheses bx minus h squared plus k. So if b is in between 0 and 1, so we're going to look at that. So we have an x squared. We're going to make up something. So like 0.25 is in between 0 and 1. So 0.25 x squared. What happens is it has a horizontal change. So you can see that graph got really, really, really wide. Okay, so from blue to red, we got really wide. But we actually call that a horizontal stretch. So horizontally, meaning side to side, this graph was stretched. It looks like someone sat on it and stretched it out. So when b is greater than 1, and again, b is on the inside with x, so like 5x squared, from blue to red, it's actually a horizontal shrink. So horizontally, side to side, it got a lot smaller. And then the next part, when h, so looking at inside with the parentheses as well, we did this on the top. So when we had a minus on the inside, it shifted to the right. And when we had a plus, it shifted to the left. So we're going to look at some equations and describe some changes. So x squared plus 4, if you wanted to, on every single one of these, you could plug these in. So we're looking at x squared and comparing it to x squared plus 4. What happens is the red moves up 4 units. In order for something to go to the right, we need to put a minus in parentheses with x. And if I'm not sure, I can write my equation and then double check it. I have x minus 3 squared, and when I click graph, I can make sure that what I just wrote did go to the right 3 units. So to reflect across the x-axis is going to be a negative. A vertical stretch we did on day 1. Vertical stretches go on the outside of the parentheses, and then to go up 1, we would add 1 to the end. So if I wanted to double check that, I could do negative 3x squared plus 1 and compare, so that did flip. It did stretch vertically, and the vertex moved up 1. The next one, we have a negative, so that's going to reflect across the x-axis. And then a minus 2 that is not in parentheses is going to move things down 2 units. The next one, horizontal compressions go on the inside. So a horizontal compression means there's going to be a 4. Compression and shrink mean the same thing, so remember that. 4 is going to go inside with x, and then to go to the left, that's also going to go inside the parentheses. So remember, anything inside the parentheses is the opposite. So vertical stretch and shrink we learned yesterday. Horizontal stretch and shrink are in parentheses and the opposite of vertical. And then to go to the left, we normally do a minus 6 on the coordinate grid. So to go to the left, we do plus 6 because what's on the inside is always the opposite. And then this last one, 2 is on the outside, so it's going to be a vertical stretch because it's a big number. We're going to go to the right 5, and we're going to go up 7. And we actually have 2 more problems. Another horizontal stretch, so that's going to go on the inside with x. And then this last one, we're going to reflect over the x-axis. We don't learn anything that reflects over the y. We would go to the left in, and we would go down m. But we don't know what those are, so we just leave them as in and m. So problem 4. they want us to write our equation. We're going to write this in vertex form. So we have a reflection, so I need a negative. My A value is 1, so I don't need to put anything in front. It does not go left or right, so I don't need parentheses, but it does go up 2. And if you wanted to, you could write like reflect and goes up 2, and then use that to write your equation. My domain for all quadratics is always all reals. And then my range, we start here at 2 and we go down. So y is less than or equal to 2. This next one, my vertex, I'm going to identify that first, is at 2, -4. So my axis of symmetry is x equals 2. And then for my equation, my A value point to point is 1 to 1. So my A value does not change. So I need x minus 2 squared and then a -4. Remember, your vertex is always the opposite for x, so whatever goes inside with x is the opposite sign. Problem 6, my vertex is at 0, 0. My A value is 1 and 1, so this does not have any changes. And my axis of symmetry is x equals 0. So remember, this is the parent function that we can use to compare all other graphs to. So the next part on 7, they're asking us how these two graphs compare. So all we have to do is plug them into y1 and y2 and see what happens. So remember, on your calculators, when you type in x squared minus 5, whichever graph you type in first is going to be the one that shows up first. So you don't have to have a super fancy calculator to see which one's which. You just have to really pay attention whenever you whenever you click graph. So mine is blue then red, but you can do first graph and second graph. So the first graph and the second graph. So wow, a lot of stuff happened. Let's look at the above and below because that's usually the easiest for us to see. So the y1, they're comparing, oh, these should all have no 3s. So sorry. These start down at -5 and then we go up 13 units. So this one is 13 units underneath or below. So anything that doesn't say below, I would cross out. I know we actually have our answer, B. So there's a horizontal stretch and it is 13 units below. Okay. And even if you left those 3s in there, there is still a horizontal, actually that stretch goes away. So it's a vertical stretch and a horizontal stretch that would cancel each other out. All right, and then for problem 8, we have what steps transform the graph of x squared to that one. So if you're not sure, always plug into the calculator to see what's happening, or even if you have finished it and you just want to check your work, you need to make sure you always check in the calculator. So when I click graph, here's my x squared, and then here is my adjusted. So I can see that it was reflected. I can see that it was stretched by 3. It looks skinnier. I can see that it moved to the left 4 and went up 2. So I'm looking for an answer that has all of those. A says that it goes to the right, which is not true. B has all of those things except it's missing a reflection. C is missing a stretch, and D is the only one that has all of those options.